Welcome to my next video. In the previous video, we learned the introduction part of units and measurements. Now in this video, we will continue the chapter and understand the international system of units in simple way. So today we are going to discuss about the international system of units. There are four system of units. So let's take one example and understand that easily. Imagine three students are measuring the same table in their classroom. One student says the table is 6 feet long, another says no, it is 2 meters, and the third says it is 200 centimeters. Now everyone is confused which one is correct. Actually, all are correct, but they are using different system of units. A system of units means a standard way to measure things like length, mass, and time. There are four system of units. First one, that is FPS, foot, pound, second. So it is used for C, that is length, that is foot, and mass, that is pound, and time, that is second. Example, you can take a height of a person in feet. So mostly used in countries like USA. Okay, then next we are going to see about the MKS system, meter, kilogram, second. So it is used for what? Length, that is meter, mass, that is kilogram, and time, that is second. Example, you can take that as length of a road in meters. So it is used in science. Okay, then next it is CGS system, centimeter, gram, second. So used for what? See, length, that is centimeter, mass, that is gram, and time, that is second. You can take the example of length of a pencil in centimeter, used for small measurements, right? So next is SI system, most important. So system of international unit, it is used for length, that is meter, mass, that is kilogram, time, that is second. Example used everywhere in school, science, and daily life. Earlier, different systems were used. This created confusion, so the world decided to follow only one system, that is the SI system. Now let us understand fundamental quantities. Fundamental quantities are basic physical quantities. They do not depend on any other quantities. They are the foundation of all measurements. There are seven fundamental quantities which are very important. So first one, that is length. It measures distance, and SI unit what we have, meter, and symbol, that is m. Example, you can take a length of a table or distance between 2 points. Then next one, that is mass. It measures amount of matter. SI unit what we have, kilogram, kg. Example, mass of a bag or book. So next, that is time. It measures duration. So SI unit, that is second, and symbol, that is yes. Example, you can take time taken to complete a task. Then next, temperature. It measures hotness or coldness. SI unit we have, that is Kelvin, and symbol, that is K. Example, temperature of water, hot body. Fifth one, that is electric current. It measures flow of electric charge. SI unit, that is ampere, and symbol, that is A. Example, you can take a current in a bulb or fan. Sixth one, that is luminous intensity. It measures brightness of light. SI unit, candela, symbol, that is CD. Example, you can take that as brightness of a light source. Then last, that is amount of substance. It measures number of particles, and SI unit we have mole, and symbol, that is mole. Example, amount of chemical in a reaction. These seven quantities are called fundamental quantities because they are basic, they are independent, all other quantities are derived from them. Example, speed is equals to distance divided by time. Here distance and time are fundamental quantities. So understand SI system and fundamental quantities is very important because they are the base of physics. Next is supplementary quantities. So see that what does it mean? Supplementary quantities are additional quantities used along with fundamental quantities. There are two types. First one, that is plane angle. Plane angle is the angle between two lines in a flat surface. So you can take 2D dimensions. And SI unit we have radian, rad. An example you can take that as angle of a triangle or angle between two lines. Next we are going to see that is solid angle. What does it mean? See, solid angle is the angle in 3 dimensions, that is in 3D space. So SI unit we have steradian and symbol that is SR. For example, light spreading from a bulb in all directions. So this is about the supplementary quantities. So remember that SI unit and symbols. Then next we are going to see about the significant figures. Significant figures are the reliable digit plus the first uncertain digits are known as significant digits or significant figures. So see the example 1.63. So 1.63, that is what? Reliable digit, and 3, that is uncertain digit. So what is significant figure? The reliable digit plus the first uncertain digits are known as significant digits or significant figures. Another example you can take, that is 0.0050830. Here leading zeros, that is 0.00. Then next these zeros come before the number. They are not significant. They only show position of decimal. 583, that is non-zero digit. These are always significant. Then next 0 between 5 and 8, in between zeros. These zeros is significant because it is between non-zero digit. Last 0, that is trailing 0 after decimal. This 0 is also significant because it shows accuracy. So in 0.0050830, significant digits are 50830. Total 5 significant figures are there. Next we are going to see about the rules for significant figures. So it is very much important to see the first rule. All the non-zero digits are significant. For example, that is 1, 2, 5, 6. Here 4 significant figures. See the next example 7.3568. Here we have 5 significant figures. So digits like 1, 2, 3, 4, 5, 6, 7, 8, 9 are always important. So we count all of them. See the next rule number 2. All the zeros between two non-zeros digits are significant no matter where the decimal point is. For example 2026. Here 4 significant figures. See the next example 200375. Here 7 significant figures. So zeros between numbers are important. So we count those zeros also. See the third rule. If the number is less than 1, the zeros on the right of decimal point but to the left of the first non-zero digits are not significant. For example, 0.002325. Here we have 4 significant figures. 0.02153. Here we have 5 significant figures. So zeros before the first non-zero digit are not important. They only show the position of decimal, so we do not count them. Fourth rule. The terminal or trailing zeros in a number without a decimal point are not significant figures. So terminal means what? End part. Okay. For example, you can take that as 26700. 3 significant figures. 7000. Here we have 1 significant figure. Zeros at the end without decimal are not clearly meaningful. So we do not count them. So rule 5. The trailing zeros in a number with a decimal point are significant. As I said, trailing or terminal, that is end point. The trailing zeros in a number with a decimal point are significant. For example, 4.500. Here 4 significant figures. So 6.2300. 5 significant figures. So zeros after decimal and after a number show accuracy. So we count them. So these rules help us to find correct significant figures. Follow these rules carefully to avoid mistakes. If you like this video, please like, share and subscribe. Thank you.